So this was very big, right? It was expanding and contracting like a lung.
This and again, the dynamic structural behavior is the key difference here to the naturally
To the
occurring
naturally occurring stuff.
zeolites.
Yeah, yeah. And so this was the first clue that it was like new chemistry.
Right.
Right?
There's something there was a more fundamental understanding that could be gleaned from continuing to go down this thought.
Yes.
This
Yeah.
thought.
And creating like way new materials that you definitely can't find.
Which so
Naturally.
the material science implication became more obvious.
Yeah.
Fascinating.
There are these minerals that are found naturally. They're called zeolites. It was discovered by the Swedish mineralogist Alex Cronstedt in 1756. This thing could absorb water, okay? And then when he heated it up, steam would come out. Okay, very simple observation. But what does that mean? That means inside the chemistry, it's trapping water molecules, right? And then as you heat it up, those water molecules are going away in the form of steam. So what that means is there's some ability of this thing to absorb chemical compounds and then put them out, right? And there's like holes inside where this water molecule is going, right? And that's why he coined it zeolite, because zeo is Greek for boil and lithos for stone. So it's like a boiling stone. And these zeolites became like a big passion of chemists because they're found naturally. Now we're gonna go to our second Nobel Prize winner, Susumu Kitagawa, and he makes this, okay? So this is in I think 1995, he publishes this, and it's a tongue and groove where he's using cobalt, nickel, and zinc ions in a 3D framework, and this is really stable. Okay.
Yes.
This is the first sort of like nice stable thing. You make this in water, okay, in a soluble sort of chemistry. That's how this thing is manufactured. You've got like these grooves that are like cross-linking to each other. And the trick is, if you dry it up, it's still stable. And it can also be used and reused to absorb gases and then let them out and then absorb more. So it's a stable compound. It's not like it's a true catalyst in that sense, right? It's not getting used up. He actually had a lot of trouble trying to get funding to do this kind of stuff.
Interesting.
Because people were like, oh, zeolites already exist. They weren't really convinced. And the thing that really convinced people was the porous crystal that he made. That's the next one. The porous crystal that he made, and that's Kitagawa on the right. The porous crystal that he made was soft in the sense that it deformed and changed its shape based on whether it had stuff inside in those cavities. Okay? So now this is something that zeolites can't do. Right? The natural occurring mineral are extremely rigid. But you've got this thing where like it can like the bonds are flexible.